Hi everyone. In this class we are going to see isomorphism definition and fundamental theorem of homomorphism. That is very important 10-mark question in unit 2. So listen carefully. What is homomorphism? A mapping phi is from G into G bar is said to be a homomorphism if for every a comma b belongs to G, phi of AB is equal to phi of A into phi of B. So here we are going to see the definition of isomorphism. Isomorphism definition is a homomorphism phi is from G into G bar is said to be an isomorphism if phi is 1 to 1. Here isomorphism means that should be a homomorphism. That homomorphism mapping phi is from G into G bar is said to be isomorphism means phi is 1 to 1. 1 to 1 means the function phi is from G to G bar means we have to take the element from G. F of A is equal to F of B. Suppose you are taking two elements A comma B belongs to in G means F of A is equal to F of B. That will implies A is equal to B. That means phi is 1 to 1. The next thing is isomorphic. Isomorphic means two groups G comma G star is said to be isomorphic if there is an isomorphism of G onto G star. We define by isomorphism symbol as G is isomorphic to G star. Then two groups G and G bar is said to be isomorphic means if there is an isomorphism of G onto G bar. You have to listen carefully here. The next thing is epimorphism. The epimorphism definition is we have to take a mapping F is from G to G dash be a homomorphism. If F is 1 to 1 then it is called epimorphism. F should be a homomorphism and also F is 1 to means we can say that mapping is epimorphism. The next thing is monomorphism. Let F is from G to G dash be a homomorphism. If F is 1 to 1 then it is called monomorphism. So here the mapping is homomorphism and 1 to 1 means we can see said this will be the monomorphism. The note, if F is from G to G dash is an epimorphism, then G dash is called a homomorphic image of G. So epimorphism means we can say G dash is called a homomorphic image of G because here F is from G to G dash. So we can say G dash is called an homomorphic image of G. The next we have to come with the theorem, that is a fundamental theorem of homomorphism. This is very important 10-mark question. For this we have 4 steps. Step 1 is we have to show that if mapping is well defined. The second step is homomorphism. The third step is onto and fourth step will be isomorphism. So here listen, the statement is let phi be homomorphism of G onto G bar with the kernel K, then G by K is isomorphic to G bar. That is G by K is isomorphic to G bar. Here they are given phi is homomorphism of G onto G bar. Therefore, we are consider the mapping phi is from G onto G bar. The next thing you have to show that G by K is isomorphic to G bar. So we have to assume that one mapping psi is from G by K to G bar. That psi is isomorphic to G by K to G bar. That is we have to show that. So in the step 1 we have to show that psi is well defined. The next one is psi is homomorphism. The next is psi is 1 to 1. The finally we have to say that is psi is on to. In final we have to come with isomorphism. So here the proof, first one is we have to consider the mapping phi be the homomorphism of from G onto G bar. The next is phi is from, that is phi is from G onto G bar defined by, already you know the definition, a mapping is from G to G bar means we have to take an element from G, that is a image, that is first one thing, that is G in G onto G bar. You have to take an element from G means that mapping of G, that is phi of G is an element of G bar. So phi of G is equal to G bar. So for every G belongs to G. The next step we have to define the another mapping sigma. That sigma is from G to G by K. Here is also we have to define like this. We have to take the element from G. So G is belongs to G. Sigma of G is equal to an element is of the form G by K. So in G by K we have the elements are Kg. Like this we have. So Kg is a sigma of G for every G belongs to G. In the next step we have to define psi. Psi is from G by K to G bar. By here is also we have to define element we have to take from G by K. So the element is of the form in G by K is Kg. So the mapping psi of Kg is equal to, in G bar we have the element, in capital G bar we have the element in G bar. So psi of Kg is equal to G bar for every Kg is belongs to G by K. And G is belongs to G. I hope these three definition will be cleared. Moreover, we have the definition in third step, psi of Kg is equal to G bar. That G bar is equal to phi of G by our given definition, that is phi is from G on to G bar definition. Phi of G is equal to G bar. So we have to consider the psi of Kg is equal to G bar, that is equal to phi of G for every G belongs to G. Now we have to come with the first step. Step 1 is psi is well defined. We have to prove that psi is well defined. So we have to take the element from G by K, because psi is from G by K to G bar. So you have to take the element X is belongs to G by K. Then in G by K the element is of the form Kg. So you have to consider that X is equal to Kg as well as X is equal to Kg dash, where G comma G dash is belongs to G. The first step you have to take in the left hand side, X is equal to Kg. Both sides you have to put the mapping psi of X is equal to psi of Kg. By our definition, psi of Kg is equal to G bar. So G bar is equal to phi of G. So psi of X is equal to phi of G. Similarly in the right hand side, X is equal to Kg dash. The same thing here you have to put psi, the mapping psi is from both sides. So psi of X is equal to psi of Kg dash. That means psi of Kg means G bar. So psi of Kg dash means G bar dash, that is G dash bar. So psi of X is equal to phi of G dash. Both the sides we have psi of X. So left hand side will be equal, means we can write right hand side is also equal. So phi of G is equal to phi of G dash. Suppose Kg is equal to Kg dash. That means these two are equal, means what happened? So phi of G is equal to phi of G dash means psi is well defined. Suppose that Kg value is equal to Kg dash means then G can be written as small k into G dash, where k is belongs to K. Hence we can write phi of G is equal to, for this we have to take both sides phi mapping. So phi of G is equal to phi of Kg dash. Phi is homomorphism, so we can separate this phi of K into phi of G dash. Here K is belongs to K, that is a kernel. So this will be phi of G is phi of K will be E bar. And that you know the definition of kernel. Kernel K means X is belongs to G, that phi of X is equal to E bar. So K is belongs to K, so we have to write phi of K is equal to E bar. E bar is an identity element, so E bar into phi of G dash. So this will be phi of G dash. Anyway, phi of G is equal to phi of G dash. So Kg is equal to Kg dash means also phi of G is equal to phi of G dash. We have to take the different element is also, we get phi of G is equal to phi of G dash. So this will implies psi is well defined. Now we have to come with the step 2 to prove psi is homomorphism. Psi is homomorphism means we have to show that psi of xy is equal to psi of x into psi of y. So we have to take two elements because psi is from G by K to G bar. So we have to take two elements from G by K, that is x comma y belongs to G by K. So x is of the form Kg and y is of the form Kg dash, where G comma G dash is belongs to G. So what happened for xy? Xy is equal to Kg into Kg dash, that is equal to K into Gg dash. This is the product of two right cosets is again a right coset of n in G. So here we have to take K is a kernel, so K is also we have like this. So K into Gg dash. So both the sides you have to put psi of xy is equal to psi of kg dash. You know that psi of kg means g bar. So the g bar can be written as phi of g. So here instead of g we having g dash, so easily we can write phi of g dash. Phi is homomorphism, so you have to write phi of g into phi of g dash. Again using the same definition, phi of g can be written as psi of kg, phi of g dash can be written as psi of kg dash. So kg is equal to x by our definition, by our assumption in the step 2 starting here itself we are writing x is equal to kg and y is equal to kg dash. So here you have to write psi of x into psi of y. So this will imply that psi of xy is equal to psi of xy. So easily we can say psi is a homomorphism. In the step 3 we have to show that psi is onto. Psi is onto means we have to show that psi is from g by k to g bar. So we have to show that every element of g bar has a pre-image in g by k. That's all. So here you have to take, let g bar is belongs to g bar. Since phi is onto, there exists an element g belongs to g such that phi of g is equal to g bar. This is also by our starting definition. The next will be phi g dash g bar is equal to phi of g, that is equal to psi of kg. This will be proved by definition itself. Thus, for every g bar belongs to g bar, there exists an element kg is belongs to g by k such that psi of kg is equal to g bar. Therefore, psi is onto. That will be simply we have to say means every element of g bar, that is every element of capital G bar has a pre-image in g by k. That will be easily proved. Step 4 is we have to show that psi is an isomorphism of g by k onto g bar. It remains to show that psi is 1 to 1. Psi is 1 to 1 means we have to show that psi of kg is equal to psi of kg dash will implies kg is equal to kg dash. That means we have to take two elements from g by k. Then you have to say that these then mapping psi of kg is equal to psi of kg dash will implies the two element will be equal. So here psi of kg is equal to psi of kg dash will implies kg is equal to kg dash, where kg comma kg dash is belongs to g by k. So first you have to take psi of kg is equal to psi of kg dash. So will implies by our definition psi of kg is equal to g bar, that is equal to phi of g. So will implies phi of g is equal to phi of g dash. So phi of g dash will be this side means phi of g dash the whole inverse, that is equal to E bar. E bar is an identity element. Phi is homomorphism, so we have to combine these two, phi of g into g dash inverse. So phi of g into g dash inverse is equal to E bar means that will be the kernel definition. So kernel definition k phi is equal to x belongs to g, phi of x is equal to E bar, then x is belongs to k phi. Like this we have to say. So phi of g into g dash inverse is equal to E bar means g dash inverse is belongs to k. So g is belongs to just g dash inverse is this side means kg dash. So g belongs to kg dash means we can write kg is equal to kg dash. Therefore psi is 1 to 1. Finally, combining step 1, step 2, step 3 and step 4, we get g by k is isomorphic to g. So we have to show that g by k is isomorphic to g means we have to define a mapping psi is from g by k to g. Sorry, that will be g bar. Kindly change that g by k is isomorphic to g bar. So we have to show that g by k is isomorphic to g bar means we have to prove 4 steps. The step 1 is psi is well defined, psi is homomorphism, psi is 1 to 1. Finally, that will be isomorphism means isomorphism definition is homomorphism and 1 to 1. Already it will be proved homomorphism, so the remaining proof will be 1 to 1 alone. In step 4 we have to show that psi is 1 to 1. So combining 4 steps we can say easily g by k is isomorphic to g bar. Girls, go through properly because this is very important 10-mark question already I told. So listen carefully. If you have any doubts, ask me. Thank you.